Here is an example where we're going to calculate the total differential. We have a function v that is a function of x and y, and we're asked to find dv, the total differential. The formula used to calculate the total differential is the first partial with respect to x, dx, plus the first partial of v with respect to y, dy. So the first thing to do is to calculate these two first partial derivatives. When we calculate the first partial with respect to x, we hold y constant. So this is a constant multiple of our cosine function. So that constant multiple just comes out and we differentiate cos xy. The derivative of cosine is minus sine xy, and then we multiply that by the derivative of the inside with respect to x, and y is a constant multiple of x, so the derivative of xy would just be y. So that's the first partial with respect to x. Now let's look at the first partial with respect to y, which means that x is being held constant. And now we have two functions in terms of y multiplied together, which means we need to use the product rule. So that'll be the first times the derivative of the second. The derivative of cos xy is minus sine xy. This time with x being a constant, the derivative of y having a constant multiple of x is just going to be x. So that's the derivative of that second term. And then to that we add the second times the derivative of the first, so that's cos xy times the derivative of the first, which is just y. With respect to y, that derivative is 1. So let's clean up these two first partials and then express our total differential function. So we'll start with the first partial of v with respect to x, which is negative y squared sine xy multiplied by dx. So we put our dx here. And then we have minus xy times the sine of xy plus cos xy. And all of that is to be multiplied by dy. So this is the formula that would be used to calculate the total differential at a given point.